the lecture. Good. So this afternoon we'll more than likely just cover the project analysis part, the ensuring projects have positive NPV. That part more than likely have to do a voiceover and load it with the recording of this lecture. And then finally, I left, so 1 and 2 relates directly to chapters 10 and 11, and 12 deals with, which is part 3 on the lecture agenda here. It's problems and investment. It's essentially a reading chapter that I'll ask you to read and go through. And throughout this lecture, I would have alluded to, or at least in the early part, what are agency problems. And those of you who might have done cost accounting with me would have come across agency problems. And I think one of the prerequisite courses for this course, which is economics, again, you would have covered agency problems, which is ever present in business operations, because oftentimes the owners and the managers are not the same. All right. Once this approach is taken, you would recognize that we would also have combined 2 lectures into one, which means that we'll have 12 lecture sessions and leaves us with 1 extra week. So that extra week, I've decided that I will do an extra quiz. So we have now 6 scheduled. Well, when we started the course, we had 6 scheduled quizzes. I'll add one more and make it 7, and I'll take the 6 best marks of the 7. All right. So as a reward, you get another chance to erase your lowest mark of the quizzes. So we'll take the 6 best marks of the 7 quizzes that we'll do. Any questions, comments? Good. At some point also in one of the quizzes or during the course, I've given many readings and I haven't really taken any questions from any of the readings that I encourage you to read. Those articles from Harvard Business Review, read them. They present sometimes, in some cases, different perspectives on the topics that I teach, but it helps to round you. So get a gist of what is included in those particular articles, right? Good. So let's get into the meat of what we do. So this slide should actually be sensitivity analysis when I load it. And the definition for sensitivity analysis is a determination of how different values of an independent variable affect a particular dependent variable, right? Given certain assumptions, this technique is essentially used within specific boundaries. And what we do is that we change one variable at a time, one input variable at a time. And it is sometimes called what if or simulation analysis. So essentially what we do in sensitivity analysis is that we have a dependent variable, and that dependent variable could be the NPV of a project. And the independent variables could be, just for simplicity, it could be revenue, it could be variable costs, it could be fixed costs, it could be taxes, right, those main items. And we say those independent variables will impact the net present value of any particular project. What we do in sensitivity analysis is to say, what if we tweak one variable at a time? So we tweak revenue. If revenue goes up by 30%, how would it affect the NPV of the project? If it goes down by 20%, how would it affect? Same thing for fixed assets. If fixed costs increase, then how would that affect the NPV of the project? If we change the life, which might be an underlying assumption of the NPV, how does that affect the sensitivity analysis? When we go through the example, you'll see how pretty straightforward it is. So just hang in. All right. Traditionally, what we do in sensitivity analysis is that we use some amount of historical costs, and then we try to predict what will happen in the future. On Monday, I think one student asked a very interesting question, asking what do we always use historical information? And just to be a little philosophical, even if we go into a particular project situation generally, and we think we can go with a clean slate. So there's a saying that you can go with a clean slate, but not an empty head. So the things that you would have experienced before, which is historical, are either consciously or subconsciously in the deliberations that you make. So it's hard to say that we can go into analysis and just forget what was historical and start. Those of you who might have done before zero budgeting and so forth, it's really, really hard, you know, because it's hard for you to, what is already in your brains is in your brains, and those are the biases that we use to predict the future, right? So sensitivity analysis, too, there are a couple of benefits. So one, it's an in-depth study of all variables, thus predictions can be more reliable. So what sensitivity analysis allows you to do is to go to examine the variables one by one, change the assumptions that you make of that variable one by one to see what will be the impact on that NPV. And by doing that, if we look and tweak revenue either up or down, tweak fixed cost up or down, variable cost up and down, we will end up with a series of different NPVs. So when we end up with those NPVs, it's more than likely that whatever we decide on will fall within that that range of NPV values that we would have predicted. So in that sense, that's where reliability comes from, right? When we carry out sensitivity analysis, by the tweaking of the various variables one by one, then we can recognize areas that we need to pay attention to. For example, we might change revenue, let's say by just 5%, and we see if we change revenue by 5% downwards, that is, that a positive NPV for that project or investment becomes negative. So immediately we have to be sensitive on how we price things and look back at how we have estimated demand. We can also look at costs. On the cost side, we can look at how 1% change in cost could affect that particular NPV value. So it might force us then to source, in the case, let's say it's variable cost, source our inputs from a more competitive market. We might be encouraged now to buy in more bulk if we're into manufacturing. So that is what sensitivity analysis stimulates. It identifies the areas that are extremely vulnerable that can turn, you know, a positive NPV calculation or estimate into a negative, and it forces you to take management actions, well, decisions and then actions to actually ensure that the project will have an NPV, right? So the example that I gave just now, if you realize that, you know, just a 5% cost or a 10% rise in cost could send you into a negative NPV, then you might want to be more strategic in how you source your raw materials. So whether it be going on a market and becoming more on a more competitive market where you can get a cheaper price, but the quality remains the same, or you buy in more bulk, or as you will see as we go on into a later lecture, there's something called options that you have. So you can essentially pay a deposit on a particular raw material that you want now to lock in the price in future. But as I said, we will go through that other option, that other tool that is available to you, which is called options, right? We say it allows for sound decisions about companies, economies, and investments because of the rigor of the analysis that you carry out, all right? But there, of course, like everything that we do, there are also drawbacks or downsides to whatever uh, analysis tool that we use, because of course none is foolproof, and there are always, as we say, some tools are more useful than the others. So there's never the perfect tool to carry out almost any analysis in management, right? So since the analysis is premised on historical data, applying to future predictions may contain error, right? Because there's also saying that you can never push your foot in a creek, in the same creek two times, because the first condition, when you push your foot, the next time the tide might change, depth of the creek might change, so many things can change. So there's never the likelihood that what happened in the past will happen again in the future, right? In the exact way. So in sensitivity analysis, oftentimes they give conditions of, let's say, and typical that they like to use optimistic and pessimistic. So optimistic and pessimistic could mean different things to different people. So it is what we call in social sciences very loaded words, very loaded constructs. So one person preparing analysis or looking at a sensitivity analysis might say that a 10% increase in sales is very optimistic. It's an optimistic condition, compared to another person who might think, 10% is not too optimistic. It's more like 30%. On the flip side of that, one person might say if cost goes up by 5%, it's a rather dismal situation and will be very pessimistic. And another person might say, no, 5% is not, that big of a deal. I'll probably think when it goes, to 15% or so forth. So those are the things when you look at sensitivity analysis, you have to get a better understanding of the preparer of that analysis, what they really mean when they use loaded words such as optimistic, pessimistic, or less likely, more likely, prevalent, less prevalent, those kind of loaded constructs, right? Without knowing the meaning of those loaded constructs, it can be, what is presented to you can be interpreted in an ambiguous way, right? And then in real life situations, when one construct change, it is often correlated with another or interrelated with another construct, or variable, right? Sorry, but variable. So it's hardly likely that, a particular material cost, let's say if you're into manufacturing, if the price of materials go up, that might go up because, the farmers might now be facing higher costs of, let's say, fuel. And you also recognize that if you have to transport your raw materials, then transportation costs could go up. So there's always a connection between, or almost always a connection between more than one construct, or more than one variable in sensitivity analysis, right? So while sensitivity analysis, we only tweak one variable at a time to see what's the impact on the NPV. In real life, it is more than one variable that is going to be changing at a time. So in that sense, sensitivity analysis could be somewhat superficial, but it's better to do something that, to carry out a particular analysis than to not have an analysis done. Are there any questions? Is the explanations clear?
Yes, sir.
All right, good. So hopefully this is the more reluctant part of the course, where you can really reason things out and not have to be bogged down by all of the calculations. So this is the part that you really act as a manager. So you have your reports or subordinates bringing, or preparing and then presenting you with those calculations, but it's now for you to really interrogate and question the calculation to ensure that the end result that is being presented to you is really viable and feasible, right? So here we presented with uh, here we presented with a preliminary cash flow for an electric scooter project. Simple cash flow. So it gives you in row one the investment that is required, row two, and this is the investment in fixed equipment, so capital, fixed assets, right? And then we have row two, this is investment in working capital. And then you have an estimation of the unit sold, the price that we expect to get from each sale. And then we calculate revenue, which is the unit sold times the unit price. We've estimated cost of goods sold to be 50% of revenue. Fixed costs we're given in row 7. Then we have depreciation. And then we have pre-tax profits, from which we calculate 40% profit, taxes, sorry. And then we have profit after tax. We now arrive at operating cash flow. And operating cash flow now, then we end up at net cash flow. But for net cash flow, we've added 1 plus column 2 and column 12, right? And then we end up at the net present value of the cash flows. We're using a discount factor of 20%. So I'll take by now that we know how to find the discount factor of 20% for year 0, 1 to 10. But once we insert that here, then we're able to come up with a net present value, positive net present value for this project of 2.02, and I think this is million, right? So this is what we're presented with here. And we're given just further information. We say the project requires initial investment of 15 billion yen. After 6 years, the company, after year 6, sorry, the company expects sales to tail off as competition enter the market. Cost of goods sold is forecasted to be 50% of sales. Taxes at 40% rate computed after deducting straight line depreciation, right? So this information that we're given on this slide here further explains what we were presented in the tabular form, right? So now we're asked to carry out a sensitivity analysis of that table that was presented. And we're using two situations, an optimistic situation and a pessimistic situation. So the way we read this table here is that we say for capital investment, remember capital investment was 15 billion yen. We say if we, in an optimistic situation, we will need 30% less of the 15 billion, right? So that's upside. So we've estimated that we need 15 billion, but when we actually get into the execution of the project, we only need 70% of that 15 billion, right? So hence we read less capital investment. But on the pessimistic side, it says that we might need 50% more of what we've estimated. So 50% more of 15 billion, that will work out to 22.5 billion, right? So we take that into consideration. So when we carry out the analysis, we only go and change one factor at a time. So in a pessimistic situation, where we require, sorry, in an optimistic situation where we say we'll 30% less capital investment is required. So that would be 15 times 0.7, 15 times 0.7. So in the optimistic situation, we'll only need 10.5 billion yen. So that will be the only figure we'll go back. So we will go back to this table here. Sorry. So we'll go back to this table here and we'll just change this figure here. So that'll change from 15 to 10.5 billion. Everything else remains the same. And we'll, well, of course, and then we'll see what the NPV will work out to. So that will be one situation. So that's an optimistic situation if we require less capital investment. If the pessimistic situation manifests, then we'll need 15, plus another 50% of that. So we need 22.5 billion yen. So again, this is the only figure we change. And then we see what's the impact on that NPV. And they've done the calculations for us. And they've said, if we need 30% less of capital investment, then the NPV goes to 5.77 billion. If we need 50% more capital investment, then the NPV goes to negative, and we have 4.22 billion negative cash flow, right? So that's a way to read this table. If we go down to working capital, we say if we need 40% less working capital, that's the only thing we change. So the capital investment will revert back to the 15 billion that we originally wanted, right? Or we estimated, sorry, but we'll only now in this case change to working capital. So we say if we need 40% less working capital, then the project will have an NPV of 3.37 billion. If we need more working capital, so that's a pessimistic situation, 40% more working capital, then we'll still get a positive NPV, but it would only be 0.68 billion yen. And we go down to units sold. We say if we sell in the optimistic situation or scenario, we say if we sell 30% more of the units that we estimated, we will get an NPV of 11.57. But if we don't do as well as we thought, and we sell 25% less, which is the pessimistic situation, then we'll get an NPV of minus 5.94. And we go down the table just as this. So unit price, if we're able to demand 10% more than we estimated, we'll have a positive net present value of 5.2 billion. If the unit price, though, we're only able to get 15% less than we originally estimated, and we go to a negative cash flow of 2.75. And we go on to the end. Look at cost of sales, look at fixed costs. All right, so once you would have done that, tweaking one variable at a time, using one condition at a time, then you can build a table of similar to this that gives you all the NPVs. So you would look here and see, based on these scenarios you set out here, which one might be more sensitive to a change, right? So that's the way we work out sensitivity analysis, and then we build a table similar to this, showing the various NPVs of the project. Are there any questions? Are there any questions?
Sir, can you please go back the table?
What particular aspect of the table?
You mentioned the part that you said to whether they reduce or increase the working capital to end up with the net present value.
Okay, good. So if we look at working capital here, the original table says, or the original calculation says that working capital, you'll need to inject these amounts. So in year one, you put 4.1 billion, in year two, 1.3, year three, 0.2 billion, and 4.3. So these are the injections that you make, right? So in the optimistic situation, it says that you will put you will only require 40% less. So instead of putting 4.1, then you'll only put 4.1 less 40% of that. So effectively, you'll only put, you only require 60%. So then you'll only need 2.46, for example, in the first year. right? And you do the same calculation, you need 40% less of this amount, 40% less of this amount, going right through, right? In the So that's an optimistic situation because you need less of cash to or working capital to inject into the business. On the pessimistic situation means you need more working capital. So instead of in this example, so let's say in year one where you had estimated you only need 4.14, but now you need 40% more. So it would be 4.1 times 1.4. So now you'll need 5.78 billion of working capital in year one. And year two, again, it will be 1.3 times 1.14, because you need 1.4, sorry, because you need 40% more, and that's how you work it. So you just change one at a time. Right? Is that clear now?
Yes, sir.
What would inform the level of optimism and pessimism? Or you arrive at?
Good. So, excellent question. So it becomes a judgment call on the preparer of the analysis. So, for example, you might, in your experience, you might have a year. Again, I must go back to last year, or even the current period that we have in. So, like the airline industry would have said, we had a bad year in, let's say, in the period 2008, 2010, when they had, or even 2007, 2010, when they had a financial meltdown, right? Business would have been bad. And you'll say, you know what? This is the worst that you could have ever gotten. So if we had a reduction in flight travel, or in air travel, sorry, by 20%, this is the pessimistic situation that we can't get worse than that. But there comes COVID-19 in
I
2020.
have no idea.
When you think the
I think
25% was pessimistic in the period 2007 to 2010, now you realize that air travel off 85%, right? So it's basically based on your experience, and some people say, well, it's based on my experience plus a little bit more, right? So it's a judgment call at the end of the day, right? And same for optimism, right? But it's just the ability for, of course, it take a couple of things into consideration. Well, it take many things into consideration. So there are several economic forecasts that is done, and they build lots of fancy models and so forth. But at the end of the day, it's still a judgment call by the humans. So it doesn't matter how much data you got, how much data you've collected, because it's all in the past, and going forward might be different. It becomes a judgment call. Right? But of course, you gotta be able to defend if you say, well, pessimistic is 50%, you gotta be able to say, I say it's 50% because of X, Y, and Z, right? It gotta be reasonable and logical, right? So anybody could say, yeah, well, I kind of agree, right? You just can't pluck it out of the skies. You gotta get some reasoning in it, right? But this is what management is about. They gotta exercise judgment in almost everything, and exercise judgment in a seemingly logical way, right? Good. Any other questions before we move on? All right, so we go to break-even analysis, which is something that we would have covered. You might have covered in economics. If you did cost accounting too, you would have covered it there. And we might have covered it when we did ratio analysis, might have covered it earlier. But break-even analysis is that point, or you break even, is that point where you make neither a profit or a loss. So you're just there. You're in the middle, right? So it's when all your sales is equal to whatever costs you've gotten up to that point, whether your fixed costs, variable costs, whatever. So it's fixed costs is equal to sales is when you have break-even analysis, right? So when we do break-even analysis, it's essentially asks how serious it would be if sales or costs are worse than forecasted, right? So how much impact do we have to suffer on sales? How much sales have to drop by before we break even, before we're neither generating a profit nor a loss, right? So that's what it looks at. How much more cost could we incur before we neither generating a profit or a loss, right? So it's very simple concept. So just remember, break even is the point where we generate neither a profit or a loss in the financial sense. In an MPV sense, it's a point where we are generating neither a positive nor a negative cash flow, right? So what we learn in break-even analysis in manufacturing or whatever, cost accounting, it is taken here now to project cost analysis. But remember, in project cost analysis, we look at cash flows. So in this sense, it is that point where you have neither a positive nor a negative cash flow, right? The cash flow is zero. Good. Any questions on break-even analysis? Do you see any other relationship with anything that you might have done before? Remember we did IRR? But the difference between break-even analysis and IRR is you look at the particular cost of capital that will give you a zero NPV, right? So one of you later in your academic life could probably take on the task of finding the true relationship between IRR and break-even analysis. Good. So they've done the calculations for us and they've said, look, if we change capital investment, if we require 16.2% more of capital investment, then the project with the scooter will generate a zero MPV, right? It will break even. If we require, then they go on to say, if we require 60.1% of working, or maybe 60.1% of working capital, then again, we would end up with a break-even situation on the project. If sales drop by 6.3%, then again, we end up with a break-even point for the project. And for cost of sales, if it went up by 3.2%, we'd have a break-even analysis, break-even point, sorry. And this is one factor at a time, right? It's not all the factors changing simultaneously. This is one factor changing at a time. And finally, fixed cost goes up by 14.5%, then you will end up at a break-even situation where there's zero MPV, right? If you're diligent, then you could go and just change the different variables by these percentages, and you should end up with zero MPV or you might just have rounding differences, right? And here they've done, in this situation, they've done, I think they've just changed the revenues. I think they changed revenues here. And they just work it out to show what a zero MPV would look like, right? So they've just looked at the minimum sales. It's the one example. So changing sales by 16.2%. This is what you end up with. And you will end up breaking even. So neither a positive nor a negative cash flow. So this is the example. Good. Then we look at break even and operating leverage. So operating leverage looks at the degree to which costs are fixed in the cost structure of a company. And as an offspring of that, we have the degree of operating leverage, which is the percentage change in profits given a 1% change in sales, right? So if sales go up or go down by 1%, what will be the impact on profits? So you have two formulas that you can possibly use. The first one is the change in profits upon the change in sales. Will give you the degree of operating leverage. Or the second one is 1 plus fixed costs, including depreciation, divided by profits. So two formulas that you can use to look at the degree of operating leverage. So remember, break even, fixed costs, once they're equal, then you get, once fixed cost is equal to revenues, then you get a break even point. So you would expect that if fixed cost is high, you would have to sell more to break even, right? If fixed cost is low, then you scale that break even point a lot sooner. So ideally, you would want fixed cost to be spread far and wide. So fixed cost per unit should be low, so that for every item that you sell, that you can break even much sooner, right? So the push is always to ensure that we can have low fixed costs. So then it gives us lots more flexibility to compete in the market, right? Questions? So if we hear a company has a high operating leverage, then we know that they have high fixed costs. If we hear that it has low operating leverage, then we know that they have low fixed costs, right? So we have an example of operating leverage. So if we use the data from year 2 in the same scooter project, so the information that was provided, we go back to year 2, we'll see that, and we're using the last of the second of the two formulas. So it's 1 plus fixed costs, including depreciation upon profits. So you'll have, in year 2, they've rounded it off to 4.5. But if you go back to the information that was provided in year 2, you'll see 4.5 free, and then depreciation is 1.5. And then you divide that by the pre-tax profit of 1.72, and that will give you 4.5. So you will say, if sales change in any direction, then the impact on profit will be 4.5%. So if sales goes up by 1%, profits will go up by 1%. If sales go down by 1%, then profits will go down by 4.5%. Right? So when you revise, just remember in this example here that they have rounded off fixed cost to 4.5. And if you look in the table that they've provided, it's actually 4.53. Right. Good. But from this example, would you say the company is highly leveraged, or how would you describe the leverage of the company? Could anyone take it? How would you describe the leverage in the company? So, all right. So typically it depends, because there are some industry that you are required to carry really high fixed costs. So it is more, when you speak of leverage, it's more of a comparative nature, not necessarily absolute, or it's more meaningful when you speak in a comparative voice and not an absolute say, because there are industries that typically the characteristics of those industry is that companies will have high operating leverage, right? So bear that in mind. If you have a question that comes, look at what is the industry average. That'll give you a fair indication of whether it's high or low. So it's high or low in comparison to what obtains in the industry. Good. All right. And then we come to a more intriguing technique that is called Monte Carlo simulation. So I know in the past we had to learn well, not me, but the much older generation had to learn Monte Carlo simulation like any other statistical technique using the books, a paper and pen. But these days, because given the powers of computers and the various software that is out there, they carry out Monte Carlo simulations for you. But what Monte Carlo simulations are, essentially they tweak all the variables. So, well, the first thing we do is to set up a model. So we will say the NPV of this project is equal to revenue minus fixed costs minus variable costs, and we might say fixed costs is a certain percentage of revenue, and variable cost might be, a certain percentage of revenue to in some step form, and so forth. So we build that whole model to say how we arrive at the NPV, which is the dependent variable, how those, and then we make some underlying assumptions. So we say there's a likelihood that revenue could go up by this percentage or go down by that percentage, and same thing for costs, same thing for fixed costs, same thing for variable costs, for tax rates and so forth. So you make all these assumptions. And what Monte Carlo simulation does is to run all those different permutations. So it might, like in the first instance, it might say, revenue go up, costs go up, tax rates go up. So that's one situation. And then they run the other situation with everything decreasing, and then another situation could be with revenue going up, costs going down, tax going up. So they run all these different permutations based on the information that you've put in. And then you end up with a whole wide range of possible outcomes, right? Having a right for that range, then you, as a manager, can see, what is most likely to happen in your judgment. Some people will take all of those various NPVs that are flushed out using Monte Carlo analysis and take an average of all of it and say, well, look, we'll end up somewhere around here, right? So using the law of averages, we'll say, well, having run the Monte Carlo simulation, given all of these different conditions, these are the wide ranges of NPV that I have. I'll strike an average of this, and the actual outcome might be somewhere around the average, right? A particular, how many standard deviation around the average, right? So that's essentially how it works. So the most critical thing as a manager now is to understand how to input the information into the software and then interpret it when it's flushed, right? So we don't have to worry anymore these days about the backdoor calculations that goes on. The critical thing is to fully understand how the project model works to end up at the NPVs that we have, right? Any questions? Oh, and I'm missing one other thing. So Monte Carlo simulation assumes perfectly efficient market, right? That's a critical underlying assumption in Monte Carlo simulation. Good. And then I explained the process just now of how so you must put in the model in the project, specify the various probabilities of how the variables might be impacted, and then you simulate the cash flows, and then you use your discount factor and calculate the present value. And then you can take an average of all those present values and say, well, this is the one that is most likely, right? Good. Any questions? All right, good. So let's push on. And then we come to real options and decision trees. So every time we have an opportunity to modify a project, right, as the project is on unfolds, then that's what we call an option, right? So we can start implementing a project, and then somewhere through the project we realize that we can, we can make a decision and take the project in a different path. Then that are called real options, right? Uh, Decision trees are similar to what we learned when we were doing probability sometime in high school. Um, so they just try to, so it's a flow diagram essentially, that you move from one point, you make a decision, you have these various paths that you can take, and depending on which path you take, you might have to make another decision and so forth until you get to, finally where you want to go, right? But it helps companies to determine the options that are available to them, right? By showing the choices and the possible outcomes. It also pictorially demonstrates to companies, the paths that they can avoid so that they don't lose profits or cash flows or value is not lost, right? And then it provides the ability to create an option, such a value that can be bought or sold, right? So again, when you run these decision trees, depending on the various paths you take or decisions you make, because there might be a point that you can just decide to abandon the project, so avoid these extra losses, or you might be even able to dispose of the project by selling it, right? So there's another thing that we should bear in mind as managers, potential managers. When we look at projects, oftentimes you might get up to a point where we think it's not, it wouldn't generate positive cash flows, and then you might just think abandoning is the only option, when in reality, someone else might be able to take that project as is. They might have the technology to make it work and thus generate positive cash flows for them. So when we get to that point that we think we must abandon, we should never forget there might be an option to sell too. So when we look at which is the most profitable thing to do, selling might be an option, right? Good. So an example of a very, very simple decision tree. So you acquire option on a future delivery, right? So you can observe growth in demand for air freight. If the demand is high, then you exercise that delivery option. If demand is low, you don't take the delivery. When we go on into, I think it's the next lecture that looks at options. So just to explain this a little bit more. So in UPS expansion option, it might be a case where they are securing payload on a particular carrier, because UPS might not have all the aircrafts to take their deliveries around wherever they go. So they can secure payload space on that particular carrier by paying that carrier similar to a deposit upfront, right? So you pay a deposit upfront, and then you have a contractual position that once you need that payload space, then they have to give you it, right? But you also have the option of not taking up the payload space if you don't have anything, if in this case, as I say, demand is low, but then you lose that deposit, right? So that's what's really happening in this particular example here. One of the other thing about options is that once you would have paid that deposit, then it kind of, generally it does, you secure that payload space at a particular price, right? Because a smart thing to do as a manager, once you would have paid that deposit, you know that UPS is taking your deposit and let it work, right? So one of the things that you want to do is to take that into account, right? So if you give them X amount of $1,000 or $1 million, if they have it for 3 months, you should be able, when you negotiate to say, well, if you have $1 million for me for 3 months, this is the likely cash flow that you can generate from having my deposit, right? So in that way, you can use that as a bargaining position to lock in a price later on, right? So in options, particularly in this example, airline industry, that's what they do. They lock in one space and lock in the price, right? So they're sure that if they don't have enough deliveries, then in just a deposit they will lose, right? And they would, and if they have high demand, they have lots of things to ship, then they have a lock-in price too, right? Any questions? All right. Good. So a couple of the real options that you have when you go through a project, you can have, you're presented with a project as is, but when you start to work through the project, you might realize that you can expand, right? You can expand that project. You can, by, for instance, investing in more equipment so that you can manufacture more, as one example. You have the option to abandon the project at a particular point because you don't want to incur, you want to limit your losses, right? As I mentioned just now, you have production options, so you can increase production, or you can even diversify your production, right? And then you can look at timing of options, right? So if you remember in one of the early classes, we did an example on, I think it was forestry, and you calculated various NPVs look at different years, and you decided that, you know, maybe if you delay the project by 2 years, or I think it was 4 years, then you get the most value, the highest positive cash flow out of that project, right? So those are real options that you have, options to expand, abandon, look at your production options, and look at your timing options, right? Questions? All right, good. So I think that's what we will cover tonight. All right, this is a more expanded one on outboard motor, using 2 different technologies. You see, in this case, they haven't used pessimistic and optimistic. They've used buoyant, and sluggish. So those are words that are very loaded words and can mean, you know, different things to different people. So as a manager, when you look at these analysis, you have to get a better understanding of what does buoyant really mean, what does sluggish really mean. Because buoyant at GT and T might not mean the same thing at Digicel, right? And then there's another example of, and this one is a pharmaceutical R&D project, which is pharmaceutical. They have their peculiar in their own way because it's multi-year. But it looks at, you know, if you invest 18 million, there's a chance that 56% chance that it would fail, or 44% that it would succeed. And then you have a potential to learn here, NPV. So you might have carried out whatever development tests that you have. So here you can go and you can invest another 130, I guess, billion. And then there's a 25% chance that you'll generate a positive NPV of 295,000, or there's a 50% that you'll only generate 52 billion, I guess, or 25% that it wouldn't be successful, right? In all cases, you have to invest a further 130, let's call it billion, right? And these are the outcomes that can happen. So 25% possibility that you can have a positive NPV of 295 billion, or 50% probability that you'll have a positive NPV of 52 billion, or, you know, it's a total failure, you end up with 0. Huh? And then you look at, could you just, and then you look on at the further step, having invested is 130, you can either succeed or fail. And you have upside of 700,000 or 700 million, a billion, or 300 billion or 100 billion, right? So there's a more expanded decision tree for pharmaceutical, because generally drugs takes a longer time to develop. There are different phases, and at any particular phase, it could, even become before it becomes commercial, it could be a failure, right? So those are 3 examples that we had. Like everything else, there's pros and cons in decision trees. So one is that it could become very complicated quickly, right? So you can imagine if you have a 3-year project with several milestones and decision points, then it can get complicated very quickly. And what was shown here in the decision tree, it might be a case of in the pharmaceuticals, you had situations where you have 3 options, but it could easily go up to 5, 10 options, right? The other thing is it allows for explicit analysis of possible future events and decisions, and it also shows that link between past decisions and decisions that you will take in the future. All right, good. So I think that's it. I think we'll cover this tonight. Take 5 minutes and let's just go through the 2 examples. Okay, let's resume. So we'll go through 2 questions. The first one, both are sensitivity analysis questions. But the first one says that the designer has to invest $5 million in a new plant for producing invisible makeup. The plant has an expected life of 5 years, and the expected sales are 5 million jars of makeup a year. Fixed costs are $2 million a year, and variable costs are $1 per jar. The product will be priced at $2 per jar. The plant will depreciate its straight line for 5 years to a salvage value of 0. And the opportunity cost of capital is 10%, tax rate 40%. So you're given 4 different scenarios. So one is, what is the NPV under the base case assumption? So the base case assumption is what is given at the top here in the question. And then B, what is the NPV if the variable cost turns out to be $1.20 per jar, right? So the base case is $1, but when we run the first sensitivity analysis, it will be $1.20. And the second analysis, we're just changing for fixed costs, which instead of being $2 million a year, it will be 1.5 million per year. And then the final one asks what price per jar would project NPV equal to 0. So in other words, at what point with a change in price, the project will break even. So let's just go through the first one. So the first, what I present to you here is the base case. So we have the units sold. We estimated that to be 6 million a year. We have to invest 5 million. So revenue will be the 6 million units times the $2 selling price. So that will give us revenue of 12 million. So you can just ignore this for now. And then direct or variable costs is $1 per jar. So we're gonna produce 6 million jars per year at $1 would give us cost of 6 million. So the contribution, remember contribution is revenue minus direct or otherwise called variable costs will be 6 million. So that's revenue minus that will be 6 million. Fixed costs in the base case scenario is $2 million per year, right? So, and then we have depreciation, which would be we said it's done on a straight line, and at the end of 5 years, it would have no salvage value. So the whole investment of 5 million would be depreciated over 5 years, straight line. So that's $1 million a year, $1 million a year. And then we'll end up with earnings before interest and tax. That's a 6 million contribution, less these costs, will give you 3 million. Taxes is 40% of earnings before interest and tax. So taxes is 40% of this 3 million. So that'll work out to 1.2 million. And then you have profit, net income after tax of 1.8 million, right? But then we add back depreciation, because here we're looking at a cash flow analysis. And we remember that depreciation is not a cash flow. But the reason why we included depreciation at the top here is so that we could get the correct earnings before interest and tax, because it's based on that figure that taxes would be calculated. So you want to get the correct tax calculation. So you included depreciation in the top just to get the correct earnings before interest and tax, and be able to calculate the correct tax. And then we add back the depreciation, right? Since it's not a cash flow. And then we'll get what is the actual net cash flow. So the net cash flow would be 2.8 million. We're using a discount factor of 10%. We should know how to apply that by now, right? And we can calculate the cash flow by the discount factor. And these are the present values of the cash flows that we will get. We add them all up together, and we get the NPV in the base case scenario of $5,614,203. Any questions on the base case calculations? Are there any questions on the base case calculations?
Sir, how you get the 25, 45, 455?
This is the cash flow, net cash flow, times the discount factor will give you this amount. So if you see, it's 2.8 million times 10% discount factor for the first year, which is 0.91. That's clear now?
Sorry, getting 25, 4,800.
How much you getting? 28? Well, it's wrong in differences. As you see that, I mean, if I open it out, you see what you get, right? But I've just rounded it to 2 decimal places. Same thing for this. If I open it out, see what it gets. But I've rounded it to 2 decimal places, right?
Thank you.
You're welcome. Good. So that's a base case calculation. Any other question? Or this should be simple by now, right? Because we've done so many calculations of NPV and so forth. So the only tricky part of this is that you should remember that you have to include the depreciation at the top to get the correct earnings before interest and tax, on which you will calculate your taxes, and then you add back the depreciation, because the depreciation is not cash flow. Right? That's the only little challenge you should probably find. But so that's a base case scenario. In scenario B, they say that fixed costs will change to 1.2 million. Oh, sorry. In scenario B, it says instead of the variable cost being $1, it will be $1.20, sorry, right? So all we do in this line here, we changed all the dollars to 1.2. So this is scenario 2, we just go change this, everything else remains the same. We change this to 1.2. And then we see what's the impact on the NPV. So the only thing we change in scenario B, when we run the sensitivity analysis, is just variable cost. Has changed from $1 to $1.20. And the impact on the NPV, now NPV moves from 5 point how much it was to 2.884 million, right? So that's all you do. Once you have the base case scenario set up, then you go one variable at a time. In this case, it's variable cost. And we're changing it from $1 to $1.20, and we see the impact on the NPV. Any questions to that? Are there any questions, or very straightforward?
Very good.
Excuse me, sir. Is
So
this always?
B. Could you repeat that, Osea? Osea?
Is this a standard form for this? Is it a standard format for this?
There's no standard format. It depends on the level of analysis that whoever the preparer would put inside. So you would imagine that in these fixed, in variable costs, that they will have like labor, raw materials, and all the other things. It's not, this is not the whole it all. Different companies will have different templates and different level of details, right?
Okay, sir.
Because as a manager, if you get a template like this, then you would want to know what is included in this variable cost. It would be reasonable for you to know. Or revenue. Yeah, we're generating 12 million revenue, but where are we getting it from in terms of geographical location? If it's, if you're selling more than one product, if you're selling the same product but different sizes. This is fashion, right? So if it's fashion, then how many different styles you're gonna carry. You're gonna need a level of details. You won't just take that. And of course, everything is depends on what the company, the level of detail the company requires, and the industry that they're in, and the preference of the managers of the day. So, right. So no standard. So we go back, we change this to $1. So we're back to where we started at the base case scenario. In scenario C, it says that fixed costs, instead of being 2 million, it's now 1.5 million. So the only thing we do for scenario C is change it to 1.5 million for all the years. And then you see the impact of this. So the impact is that the net present value goes up, right? Because comparatively speaking, from your initial underlying assumptions now to this change, then the company becomes a lot less, it has a lot less operating leverage. So we expect that the NPV should go up. So again, just one factor you change, this time it's fixed costs, NPV goes up. Right? And then the final one asks you, all right, sorry, is there any questions for this one? All right, good. Then final is at what per jar would the project NPV equal 0? Right. So here we have, let's go back to the base case. Right, so we're back at the base case, and we want to know which price that the NPV will equal to 0. Of which price. Now it is being sold at $2, right? And remember, break even is when your your outlay, you don't start generating profits. You want this to be zero, right? So one way of doing it is to take the NPV here of 5,614,000. You multiply it by the tax rate of 1.4% of 5 years, you get close to zero, but not necessarily zero. So you get 1.57, and this is just my way of doing it. I don't have a formal mathematical way of doing it. So if there's anyone else in the class who has the technique to do it, then I'll be glad if you can share it. And because we're doing it on the computer, then we don't have much to worry in terms of, but it will be easier to do it by trial and error. I see that once I input 1.57, then we get a negative NPV of 253,000. So it requires that to get it to zero, then at least the revenue has to go up. So price have to go up. So I will try 0.8 until I get to close to what zero is. Zero is. So you can try just by trial and error, go up.
Sorry,
So guarantee that I might not bring this in a quiz again.
I was going to ask, the 1.57, is this a percentage?
No. This is a price per unit.
Okay.
It's a price per unit. And then we still at 0.74, and so actually the answer is 0.9, but you can work up when you get very close to that amount. So 1.9 will bring you very, very close to zero. You still get a positive of 19,000 or something, but it's roughly 1.9, right? But I'll just do by trial and error. As I said, I don't have a better method of doing it. So those who are more mathsy and work out the formula, reverse it and work out the formula, I'd be glad if you can share it with me later, right? Good. Any other questions for this particular example? If none, then we can move on to the other one. But you see, basically, once you work out the base case scenario, you go and just change one variable at a time, then it's not really that challenging, right? So again, as I stressed earlier, that's why it's critical that you understand what's not relevant can be included. So once we get past that, then all the other analysis becomes, just tweaking something here, there, and making decisions. Right. So the second example, it says a project currently generates sales of 10 million. Variable cost equals 50% of sales. Fixed costs are 2 million. The firm's tax rate is 21%. What are the effects of the following changes on cash flow? Sales increased from 10 million to 11 million. Variable costs increased to 65%. If we look at scenario A, sales increased from 10 million to 11 million. So we have an increase in sales of 1 million. We're told that variable cost is 50% of sales. So variable cost will now be 500,000. So contribution is now 500,000. Taxes is 21%. So it's 21% of 500,000. You calculate the tax amount, you less it from contribution, and then you have an increased cash flow of 395,000. Right. So that's the impact that we'll have on scenario A. Any questions? So sales increased by $1 million. Variable cost has a direct relationship with sales of 50% of sales. So you'll get the contribution. You'll note that there's no mention of fixed costs, right? There's no mention of an impact on fixed costs here. So despite they told you that fixed cost is $2 million, in the scenario, it doesn't tell you that fixed cost goes up. So the assumption that you make is that despite sales going up, there's no impact on fixed costs. So that's the reason why you wouldn't see fixed costs included here, right? So fixed costs remains the same. So whether you do it sell 10 million or 11 million, fixed costs will still be 2 million a year, right? So the increase in cash flow would be 395,000. In scenario B, this is the one in green is what we call the base scenario. So, and this is where fixed variable cost is 50% of sales. So we have sales at 10 million, variable costs at 50% of sales being 5 million. So contribution would be 5 million. Taxes at 21% of that will be $1,050,000. So you'll have increasing cash flow of 3,950,000, right? But if it, or you have cash flows of that, not necessarily increase. But if variable costs now increase to 65%, then the only thing we change here, sales remains the same, variable costs now becomes 65% of sales, contribution drops to 3.5 million, tax rate remains the same at 21%, so it's 21% of 3.5 million, and now you'll have a cash flow of 2,765,000. So we'll say if variable cost increases from 50% to 65%, then cash flow will decrease by 1,185,000. So that is the second example of sensitivity analysis. Are there any questions?
So just excuse, can you go back briefly, please?
Could I go back over? Which one would you like me to go back over?
The second part, B, variable cost increase to 65% of sales.
Right. So in part B, the only difference, so you have the base case. So the base case tells you sales is 10 million, variable cost is 50% of sales. So we calculate 50% of 10 million gives us 5 million. So we end up with a contribution of 5 million. Taxes is 21% of contribution of 5 million, just and then sorry. Are you seeing my screen?
Yes, sir.
Okay, good. Because I just went off for a minute. Good. And then in the second scenario, it says the only thing that changes is variable cost is now 65%. So sales remains the same, 10 million. Variable cost is 65% of that 10 million, which will give you 6.5 million. Contribution now will drop to 3.5 million. So that's 10 million minus 6.5 million. Will give you 3.5 million. Taxes will be 25% of contribution. So 25% of 3.5 million will be 735,000, flow of 2,765,000. You compare the two scenarios. So this is the original scenario where you had cash flow of 3.950 million, and now it's 2.7. So you've actually had a decrease in cash flow of 1,185,000. Good. Is that much clearer now?
Yes, sir.
Excuse me, sir.
All right, good. Yeah, go ahead.
For scenario A, it would mean that the increase in cash flow would be 495 since the sales will increase by 1 million extra.
In scenario B?
A.
Yeah, right. In scenario A, sales will increase by 1 million. Hello?
We're here, sir.
Yep, so the person who asked the question, is she still there?